It's gotta be the most famous equation in the entire world, right? Just five little characters thought up by Albert Einstein back in 1905 that pretty much blew the doors off our understanding of the universe.
We've all seen it. I mean, it's everywhere. On t-shirts, in movies. It's basically the universal symbol for genius. But let's be honest, how many of us really know what it means? We see the letters, but do we actually get the incredible power it represents?
Well, that's exactly what we're going to tackle today. We're going to take this thing apart, piece by piece, and uncover the absolutely profound secret it holds about, well, the fabric of reality itself. To really get this equation, we have to go back. I mean, way, way back, to the very beginning, where the story of energy and matter gets started. Okay, picture this. Moments after the Big Bang, there wasn't any stuff, no matter. It was just this super hot, expanding universe of pure, wild energy. But as the cosmos expanded and cooled down over the next 380,000 years, something amazing happened. That raw energy started to condense. It began to transform, creating the very first atoms, the building blocks of everything we see today. And here's the absolute key to the whole thing. That original energy from the Big Bang, it never left. It just changed its clothes. This is the heart of Einstein's genius, mass-energy equivalence. Mass and energy aren't separate things. They're two sides of the very same coin. Matter, everything you can touch, is just energy bundled up in a super dense, stable package. All right, so with that cosmic origin story in our heads, let's get to the main event and decode the equation itself. Every single letter here is a vital clue in the puzzle. First up, we've got E, and that stands for energy. You know, the ability to do stuff. Think about a light bulb. It takes electrical energy and turns it into light and heat. The energy changes its form, but the total amount of energy in the system is always, always conserved. Next, M for mass. This is simply the amount of stuff an object is made of. The more particles you cram into an atom, say like uranium compared to hydrogen, the more mass it has. Simple as that. And it is so important not to get mass mixed up with weight. They are not the same thing. Your mass, the actual amount of matter in your body, never changes. Your weight, though, that's just gravity's pull on your mass. You'd weigh a lot less on the moon, but your mass would be exactly the same. And for this equation, it's the mass we care about. And finally, C. C is the secret sauce. It's the speed of light in a vacuum, a blistering 300,000 kilometers per second. That's fast enough to circle the entire Earth more than 7 times in a single second. It is the absolute, unbreakable speed limit of the universe. Nothing goes faster. But here's the real kicker. The equation doesn't just use C. It uses C squared. That means you take that unbelievably huge number and you multiply it by itself. The result is a number so gigantic it's hard to even wrap your head around. And that is the magic number. The conversion factor that explains how a tiny, tiny amount of mass can unleash an ocean of energy. Okay, enough with the theory. This is where it gets really mind-bending. Let's actually apply this formula to a couple of things you see every day, because the results, well, they're just staggering. So let's start with something super small and boring. A paperclip. It has a mass of about 1 gram. So what happens when we plug that little number into our equation? You get roughly 90 trillion joules of energy. Now, that's a number so big, it's almost meaningless, right? It's just a bunch of zeros. So what does that actually look like? It means that the energy locked inside that one tiny 1 gram paperclip, if you could release all of it at once, would be enough to boil all of Lake Tahoe. No, I'm not kidding. The entire lake from a single paperclip. All right, you still with me? Let's scale it up a bit. How about something with a mass of 1 kilogram? You know, like a cantaloupe from the grocery store. If we could take that one cantaloupe and convert its entire mass into electricity, it would generate enough power to run the entire country of Ireland for a full year. That is the kind of power that's hiding inside ordinary objects all around us. Now, I know what you're probably thinking. This all sounds like wild science fiction. Can we actually do this? And the answer is yes. Not perfectly, not with 100% efficiency, but we have figured out how to put this theory into practice. The most common way we do it is through something called nuclear fission. This is what happens in nuclear reactors. We take a big, heavy atom like uranium, and we literally split it apart. When it breaks,
A tiny, tiny fraction of its mass just disappears. It vanishes. And in its place, just as the equation predicts, a massive burst of energy is released. And the difference in power is it's off the charts. Look at this. If burning 1 kilogram of coal gives you 1 unit of energy, a kilogram of dynamite gives you just a little bit more, about 1.6 times. But that same kilogram undergoing nuclear fission, it releases 3 million times more energy. That's the power of E equals mc squared.
So let's pull it all together. What's the ultimate lesson here? What does this equation really teach us? Well, it reveals a beautiful, fundamental cycle that's at the very heart of how our universe works.
The universe, you see, is a closed system. Mass is constantly converting into energy. It's happening inside stars right now. And energy converts into mass, just like it did after the Big Bang. The key is, nothing is ever truly lost. It just changes its form. The total amount of mass and energy in the universe has been and always will be the same.
So E equals mc squared isn't just a math problem, it's a description of reality. It means that every single thing around you, the screen you're looking at, the chair you're sitting on, your own body, it's all just a structured, condensed form of ancient energy. It's all connected. Which really makes you wonder, doesn't it? What other huge, universe-defining secrets are hiding right in front of us, just waiting to be discovered?